Hi everybody. Right, welcome to physics teacher classes. What is our lesson? Kinematics. Right? So in the before session we learnt about the definition of kinematics and rest and motion terms. Right, Nana? Today we are going to learn two more terms. They are distance and displacement. Distance and displacement. Okay, so these two terms we are going to discuss today. So yesterday I said kinematics. What is kinematics? Kinematics is a branch of mechanics which deals with the motion of an object, right, Nana? And rest and motion we have seen. Now let us see distance and displacement. Suppose you are going from your house to school, for example, right? This is your house and somewhere is your school, right? Now you are moving from your house to school. So there are different ways to move from your house to school. So for example, this is one way to move your house to school, and this is another way. Right, this is let us take this the first way and this is second way. If you move in this way, you may cover, for example, 500 meters. You walk through 500 meters. If you move in this way, you may walk through 300 meters. Understood? So now here, which is distance, which is displacement? Let us see that. First, what is meant by distance? Distance is nothing but the total length of the path covered by the body. What is that? Total length of the total length of the path covered by the body. Covered by the body is known as a distance definition. So what is that? The total length of the path covered by the body. Path means in which you are traveling. So the total length of the path. The total length of that path is nothing but the distance. Okay. Here if you choose the first path, what is the total length of this path? 500 meters. So how much distance you have covered? 500 meters. If you choose the second path, what is the total length of the path here? 300 meters. So what is the distance traveled by you? 300 meters. Understood? So distance is nothing but the total length of the path covered by the body. Let us see another thing. For example, you have started at point P and moved to point Q. This is 5 meters, and moved to point R, which is 4 meters. Right? Now what is the total distance you have traveled here? Distance is nothing but total length of the path covered by the body. Total length of the path. So 5 meters plus 4 meters. What is the distance? 9 meters is the distance. Understood? So in this way one can calculate distance covered by the body. Right, Nana? And it is denoted by letter. It is denoted by letter S. English letter S. Alphabet is S. You can write small s or capital S. Distance is denoted by small s or capital S. Understood? Now what are the units? So as this is the distance is nothing but the length. Okay, length of the path. What is that? Length of the path. We know the units of length. Already we learned in measurement lesson. Right, Nana? So what are the units of length in MKS system? That is meter. In CGS system, that is centimeter. In SI also it is meter. Right. So some other units we have. What are they? Kilometer. We know that 1 kilometer is equal to 1000 meters. Right. Similarly, 100 centimeters is nothing but 1 meter. 100 centimeters is 1 meter. So these are the units of what are these? Simply units of distance. Okay, in MKS it is meter, or in SI also you can take that as meter. CGS is centimeter. 1 kilometer is nothing but 1000 meters. Okay, 1 meter is how many centimeters? 100 centimeters. Another thing is there, 1 millimeter is equal to 1 by 10 centimeters, or you can take this as 1 centimeter is equal to how many millimeters? Right, so 1 centimeter I am writing here, 1 centimeter is equal to 10 millimeters. This is the smaller unit, right? No. So this is about distance. Simply distance is nothing but the total length of the path covered by the body, and it is denoted by letter S. Okay, and the units are these. Clear? Now coming to second term, displacement. So displacement is nothing but simply I am giving, it is the straight line. What is that? Straight line drawn from, okay, drawn from initial point to final point. Initial point to final point. This is displacement. Okay, what is that? A straight line drawn from initial point to final point. Okay, you need to identify first which is initial point, which is final point. Means where the body is starting, that is the initial point. Okay, where the body is going to stop, that is the final point. Or means from where you are observing the body, okay, until what distance you are observing the body. Okay, na? So these are initial points and final points. Now see in this example, house is your initial point and school is your final point. So that if this is the initial point and this is the final point, you just draw a straight line, okay, connecting these two. This is the displacement. Understood? So the dotted line, what I am showing here, drawing here, is the displacement. What about here? Displacement, which is that? Which is the initial point? You are starting from point P. Okay, you are moving up to point Q. Then initial point to final point. What I should draw? I should draw a straight line. This gives the displacement of the body. Understood, Nana? So displacement can be defined as the shortest distance. It is the shortest one from initial point to final point. Clear, Nana? Now regarding this displacement, you should remember that it is denoted by S bar. What is that? S bar. So I have written arrow on the head of the alphabet. That means it is a vector quantity. What is this? It is a vector quantity. So that it has magnitude and direction both. Okay, na? So displacement is a vector quantity. It has magnitude as well as direction. Clear, Nana? But whereas distance, it is a scalar physical quantity. It is what? Scalar physical quantity. But displacement is a vector physical quantity. See that its symbol is simply S, but it is S bar. Okay. What about units? Okay, units same as distance. Same as distance, because distance and displacement both are length. Okay, na? So here what is the displacement? Length of this straight line. What is the displacement? Length of this straight line gives the magnitude of displacement. Understood, na? So in this way one can calculate displacement of the body, right? Now see here, the important thing is, in the line which we are drawing from initial point to final point, okay, there may or may not be a path. Understood? Here there may or may not be a road here also, but the displacement is no need to travel in this way always. Okay, displacement is nothing but a straight line, or the distance, shortest distance is taken from initial point to final point. That should be the shortest one. That should be the shortest one. Shortest one is nothing but the straight line. Okay, than straight line, no other shortest paths will be available. Clear this? So in this way we will be identifying which is displacement. Now here it may be 100 meters. It may be 100 meters. Understood? In this case, what is the displacement? Displacement is equal to just 100 meters I am drawing. Okay, what is this 100 meter? 100 is the magnitude. Okay, then what about direction? Then we'll be identifying, we'll be calculating by using some mathematical tools. We can calculate the direction also. Direction is nothing but angle, already we discussed, right? Now here, what is the displacement in the second case? In this case, what is the displacement? See, this is 5 meter and this is 4 meter, right? So it is a right angle triangle, let us assume that. Then what could be the hypotenuse? Then this is root over, in this case displacement is root over 5 square plus 4 square. Okay, that is equal to 25 plus 16. Yes or no? Yeah, that is root how much? 41 meters is the magnitude of displacement. Okay, if anyone asks what is its direction, then we can calculate the angle, right? So in this angle is tan theta is equal to 4 by 5, so that theta is equal to tan inverse of 4 by 5 is the angle, means this is the direction, this is the magnitude. Understood, Nana? So in this way one can calculate magnitude and direction of the displacement. Clear? So the thing you need to remember is distance is nothing but we will be calculating total length of the path covered by the body. Displacement is nothing but just the shortest one you need to draw first, that is from starting point to ending point. Just you draw a straight line, then you calculate its length, that will be your displacement. Okay, and what are the things you need to remember? Distance is a scalar physical quantity, displacement is a vector physical quantity, and the units are same. Units are same for distance and displacement because it is the length. Okay, now let us see some more examples how to calculate distance and displacement. Right, let us see here a person is moving. Okay, first he is moving from point, this point. Okay, this point I am taking as initial point, right? He is moving in this way, that is 4 meters. Okay, next coming down. Okay, this is 5 meters. Next moving to left again 2 meters. Okay, so in this way the object has moved. Now the thing is we need to calculate here distance and displacement. Okay, na sir? Now what is the distance in this case? Distance is nothing but total length of the path. Okay, so 4 meter plus 5 meter plus 2 meter. Yes or no? How much is this? 11 meter is the distance, right, Nana? Now let us calculate displacement, right? So what is displacement? Let us see here. So displacement is nothing but what I said, it is the straight line drawn from initial point to final point. Which is initial point? This is. Which is final point? This is. Now just you draw a straight line, that gives the displacement. Understood? Then how to calculate its length? So here let me draw a perpendicular from this point. Okay, now this is 5 and this is also 5 meters. As this is 2, this is also 2, and what will be this distance? 2 meters. Now I got a right angle triangle which is 5 and 2. Then that is root over 2 square plus 5 square. Okay, na? Pythagoras theorem. That is 4 plus 25. That is root 29 meter is the displacement, magnitude of displacement. Okay, then how will be calculating angle? Okay, the angle made by the displacement with 5 meter also you can calculate. How, sir? If you take tan theta is opposite by adjacent, that is 2 by 5. This gives the direction of the displacement. Understood? In this way one can calculate distance and displacement very easily. Let us see some more examples. Now see here. Okay, an object starts from the origin and it is moving on the x-axis. Let us take this as x-axis. Okay, so it is moving on the x-axis, right? The object is starting from the origin, right, Nana? So first it is moving. This is the object, let us say, moving towards the positive x-axis. So it moves up to point A. Okay, later it moves to point B. Point A is at a distance of let us take 10 meters, and point B at a distance of 50 meters from the origin. Right, now what happened? The object turned back. It is moving O to A and A to B and turned back and coming in the same position. Okay na? And it crosses the origin and it moves up to a point C. Now C is at a distance of 20 meters from the origin. Understood? So this is the way in which the body has moved. Right, now in this I want to calculate distance and displacement of the object for different segments. First I would like to calculate distance and displacement from O to B. O to B, what is the distance and what is the displacement? Okay, now what is the distance from O to B? That is OA plus AB. Yes or no? Now OA is 10 meters plus OAB is 50 meters. Then what is the distance? Very good, 60 meters is the distance. Coming to displacement. Okay, which is the initial position? O. Which is the final position? B. What I should do? I should draw a straight line. Okay, then OA is my displacement vector. Okay, OA is my displacement vector. What is the length of this vector? 10 plus 50, that is 60 meters. Understood? You observe carefully here. In this case, distance is equal to displacement, sir. In this case, distance is equal to displacement. Is it possible in all the cases? No. When it is possible? When the body moves in a straight line and never returns, distance and displacements are equal. Remember this point. When distance and displacements are equal. So, when the body moves in a straight line and never returns, okay, it should be moved in a straight line and stops at that position. It never returns, then the distance and displacements are equal. Understood? Now coming to next, let us see O to B to O again. Understood? It moves from O to B and B to O it has come. Returned and come to this. Okay. Now let us see what is the distance in this case. What is the distance? OA plus AB, OA plus AB plus BA plus AO. Yes or no? It is moving from O to A to B, again returned BA and OA, AO. Now OA is 10, AB 50 plus BA 50 plus AO 10. Now what is the total? 120 meters is the distance covered by the body. Understood? Now what is the displacement in this case? Which is the initial point? O. It started at point O. Okay. Which is the final point? Again O. Right? What is that? 0. This is the starting point. This is the ending point. If I draw a straight line here to here, what is the length of that straight line? 0. Nothing. So in this case, displacement is 0. You observe one point here. Here, distance is not equal to 0, but displacement is 0. Understood everyone? So when displacement is 0, when the body comes to the starting point. This is the starting point. Again, it returns to the starting point. So the displacement is 0. Understood? This is null vector. What is this? Null vector. Okay na? Or 0 vector also you can call. So when the body comes to the starting point, the displacement is a null vector. Simply you can say. Okay na? Now let us see the third case. Okay. O to B to C. Now third case. It has moved from O to B nana. Next B to C. Okay. Now what is the distance? See this? It is OA, tell me, AB plus BA, okay, plus AO plus OC. Am I correct? Yeah, now 10 plus 50 plus 50 plus 10 plus 20. right? How much is this? 140 meters. So in this case, what is the distance? Distance is 140 meters. Now coming to displacement. Which is the initial point? O. Which is the final point? C. Okay, what is the, if you draw a straight line, this is the vector, displacement vector. What is the length of that displacement vector? 20 meters. Okay, but it is minus. It is minus. Why, sir? Why it is minus? See, that body crosses the initial point. Body crosses the initial point, means starting point it has crossed and moves backward direction. Right, Nana? So this is why the displacement is minus 20 meters. What is its direction? Here it can be written as displacement can be written as in two ways. How? Displacement is equal to, okay, 20 meters. Displacement is equal to 20 meters west. Okay, now. So if you draw directions, this is east, west, north, south. So the displacement is in the direction of west, backward, or it can be written as displacement is equal to minus 20 meters east. Okay, because we have changed the direction of the vector, so it is minus. Understood? So in this way one can calculate distance and displacement. Now you observe carefully in all these three cases. Okay, distance never be negative, never be zero once the body starts. Okay, but displacement can be positive, zero, negative also. Yes or no? In the second case it is 0. In the third case it is negative. In the first case it is positive. Okay, but you observe distance. Distance is always positive. It never be 0. This point you need to understand from this example. Okay, now. So distance never be 0. And one more point is distance is always greater than displacement, or distance is equal to displacement. Okay, see, in all the cases distance either greater than displacement or equal to displacement. Understood, Nana? But distance is never be less than displacement. Distance is never be less than displacement. Why? The reason is displacement is nothing but the shortest. Yes or no? Displacement is nothing but the shortest. Than that shortest is not possible. So that distance is never be less than displacement. Okay? It's not. Never be less than displacement. Always distance either equal or greater than displacement. Understood this one? So in this way one can calculate problems based on distance and displacement. Now let us see some more situations which will be asked in examinations, how to calculate distance and displacement. Okay, now let us see if the body is moving in a circular path. Okay, let us see how to calculate distance and displacement. That means a body is moving in a circular track whose radius is r. Let us take radius of the circular path is r. Okay, now the first body has started at point A. Right, Nana? It is moving on the circle and reaching at a point. Now B is the diametrically opposite point. Okay, point B is the diametrically opposite point on the circle. Okay, now let us take C is the 1/4 of the circle. Okay, B is half of the circle, C is 1/4 of the circle. Similarly, D is a 3/4 of the circle. And this way I just put a points on that. Now first the body is moving, first case in A to A. Okay, it is moving in one round. It completes how many rounds? One round. Okay, now I want to calculate what is the displacement and what is the distance and displacement. In this case, what is the distance? Distance is nothing but, okay, it has started at A, again coming to A. Okay, this is nothing but circumference of the circle. Okay, circumference of the circle. What is the circumference of the circle formula? That is 2 pi r. So in this case, what is the distance traveled by the body? 2 pi r, where r is the capital R is radius of the circle. And what is pi? Pi is a constant. Its value is 22 by 7. It is just a constant in the circle. Its value is 22 by 7. You remember that. Now what is the displacement? You can tell me. A to A. This is the starting point. And which is the ending point? This is the ending point. So that displacement is a null vector. Very good. Yes or no? Nice. Okay. So in this case, displacement is 0, but distance is 2 pi r. Clear, Nana? Now let us take second case. It moves from A to B on the circular track. Okay. Means it is starting from A and moves up to point B. Right. In this case, what is the distance? Half of the circumference of the circle. Yes or no? If it is completed full circumference. Now it has moved up to half. Okay, then half of the circumference of the circle, that is half into 2 pi r, that is pi r. Got it? Now what is the displacement? This is the initial point and this is the final point. Just you draw a straight line. Okay, what is the length of this straight line? This is r and this also will be r, so that is 2r. Got it? So length of the straight line is how much, Nana? R plus r, 2r. Right? Now the third case is it moves from A to C, means 1/4 of the circle. 1/4 of the circle it has moved. This is half. This is full, means one round. Now in this case, what will be the distance and displacement? Okay, as it moved 1/4 of the circle, then the distance is 1/4 of the circumference. Okay, that is pi r by 2. Clear? Now what is the displacement? Now which is the initial point? A. Which is the final point? C. Just to draw a straight line. This is the displacement. That is AC. Okay, then how to calculate its length? You observe carefully, as this is r and this is also will be r. Am I correct or not? Because this is the radius. Right, now you have a right angle triangle. In the right angle triangle, length of the hypotenuse is equal to square root of r square plus r square. Okay, that is equal to root over 2 r square. It can be written as r root 2. What is the displacement in this case? R root 2. Got my point or not? Yeah. Now see, it moves from A to D, Nana. Last case. A to D. Means from A it has started and moved up to D in the anti-clockwise direction. Let us take. Okay. Now let us see what is the distance. It covers 3/4 of the circle. So 3/4 of 2 pi r. That is how much? 3 pi r by 2. Yes or no? Right, very good. Now what is the displacement? Let us calculate displacement in this case. Now displacement is how much? So displacement is nothing but starting point to ending point, you draw a straight line. That is the displacement. That is AD vector. Vector AD is the displacement. Clear? Now how to calculate this? Again you see the center to D is r. As this is r and this is r, how much will be that? R root 2. Similarly, in the A to C, the length of the vector A to C, and this also same, r root 2. Understood? In this way, one can calculate distance and displacement when the object is moving in a circular path. Okay? Right, Nana? This is very simple. Okay, distance is circumference. Displacement is the straight line distance. Okay, length of the straight line. Okay, now in some competitive examinations like ncert, IIT and different competitive NTSC like that, they'll be asking the questions. Now when the body moves in a circular track of radius r, a body is moving on the circular track of radius r and it covers an angle 60 degrees is given. It moves from A to B. So as it is moving from A to B, how much angle it has covered? 60 degrees. Then what is the distance and what is the displacement. In this case, how, sir? Because we don't know whether it is half of the circle or 1/4 of the circle or half of 1/4 of the circle. Right. For this we have a formula to calculate a displacement. First I will be giving. Okay. That is 2r sine of theta by 2. Remember this formula. It can be derived by using vectors. Okay. So this is a vector r, and this is also another vector r. Yes or no? As it is red. Now what is the displacement A to B? Let me draw with the red. This is the displacement vector. AB is the displacement vector. Clear? Now how to calculate AB? Let us see. This as O. Okay. R plus this displacement, let us take something S bar or S whatever. R plus this S minus R is equal to 0 in the triangle. How, sir? See, this is vector and this is another vector and this is another vector. You observe carefully, 3 vectors are there. Yes or no? Now let us take this as A, B, C. In this triangle, how can we write A plus B plus C or minus C? As it is opposite or correct? So minus C is equal to 0. Yes or no? Because vector C is not in the order of A and B. A and B are moving in the clockwise, anti-clockwise direction, but B is opposite. So this I can write, I want to calculate B kada. Okay, then B is equal to C minus A. B is equal to C minus A. Okay, now what will be the resultant of this? Magnitude of C vector minus A vector. How to calculate this? Root over C square plus A square minus 2AC cos theta. Root over. If you simplify this, you will be getting the answer. Here C is how much? R. Okay, A is how much? R. Then that is R square plus R square minus 2R into R square cos 60. 60 value how much? Sorry, cos theta value? Cos 60 degrees. Okay, instead of that you take theta only. Root over. If you simplify this, then you will be getting 2r of sine of theta by 2. Okay, Nana? So in this way one can calculate displacement directly. Now substitute in this formula 2r sine of 60 by 2 means sine 30. Yes, that is 2r sine 30 is half. Then what is the answer? R is the displacement. Okay, when the theta is 60 degrees, what is the displacement? That is equal to radius of the circle. Then how to calculate distance? Displacement is over. Okay, distance, for that also I will give a formula. That is theta by 360 into 2 pi r. Theta by 360 into 2 pi r. Now see that theta is how much? 60 by 360 into 2 pi r. 60 how many times? 6 times. 2 1 ja, 2 3 ja. What is the answer? Pi r by 3 is the distance. Got it? So these are the formulas related to distance and displacement when angle is given. Just you remember this. When angle is given, how to calculate distance and displacement. Displacement is this, distance is this. Okay. So how, if the body completes 1.5 round or 2 rounds, how to calculate distance? So here you will be taking just n. Okay, n will be 1 if it completes 1 round. Okay, if it completes 1.5 round, you will be taking 1.5. If it is 2.5, 2, whatever it may be, you take that value. That n should be greater than 1. The n value should be greater than 1. Means it should complete 1 round and above, then only use n. Otherwise just you take theta by 360 into 2 pi r. If it completes, if n is greater than 1, then theta value always you should take 360 only. If it is 1.5, then 360 by 360 into 2 pi r into 1.5. If it is 2 into 360 by 360 into 2 pi r. Okay. Now the thing what you have to do is just to apply these formulas to these relations. What we got? Now see here. First A to A. It moves from A to A. What is the angle? It completes one circle, so it is 360 degrees. Yes or no? Then 2r sine of 360 by 2, that is sine of 180. Sine 180 is 0. So this value is 0. See? Now distance. Distance is n is 1. Okay, 360 by 360 into 2 pi r. 360 by 360 is 1. 1 into 2 pi r, 2 pi r. Got it or not? Now let us see A to B. Okay, what is the angle covered A to B? 180 degrees. Okay, na? 2r sine 180 by 2 means sine 90. Sine 90, 1. 2r into 1, 2r. Got it or not? Yes. Next here. Okay, n is not greater than 1, so forget about that. Now theta is how much? 180 by 360 into 2 pi r. So this value gives 2. Right, Nana? 2 gets cancelled, pi r. So the distance is pi r. You apply for whatever the angle, you will be getting the results. Understood? Just to remember, distance and displacement formula is this. Displacement is 2r sine of theta by 2. Distance is theta by 360 into 2 pi r. When it completes more than one circle, then n value you should take. And when n value is greater than 1, then the angle is 360 degrees you must take. Clear? Everyone? Very good. Now let us see one more problem. Okay. Now see that it is given in previous competitive examinations. There is a ring, circular ring, like we will be moving tire on the road. Let us take this as a tire. Okay, this tire, a child is moving on the road. Okay, we are observing the point A on the tire, right, Nana? So when he rolls the tire, it comes to this point. Suppose when it comes to this point, okay, the point A has come here. Understood? Now the tire is moving in this way. The circle is moving in this way. Okay, it is moving in the clockwise direction. Then while it is moving, the point A has come here. Understood? Now I want to calculate distance and displacement of that point A. Clear? Distance and displacement of that point A. Right, how to calculate distance here? Now observe carefully, this point has come here. Yes or no? Then it completes half of the circle, so that it is half of the circumference of the circle. That is how much, sir? Pi r is the distance. Clear? Now what is its displacement? Which is the initial point? A. Which is the final point? A. This is the displacement vector. Now I want to calculate length of this A to A vector. Then how? I need to form a right angle triangle here. Point this to this, and this is. How much is this length? This is 2r, because this is the diameter of the circle. And how much is this value? Already we have calculated. This is pi r. Yes or no? This is the distance traveled by the body. So now what is this value? That is root over 2r square plus pi r whole square. It has given in previous IIT exams. That is 4r square plus pi square r square root. It can be written as r square. If you take common, r will be coming. That is 4 plus pi square. And this way one can calculate. Understood, Nana? So identify which is distance and which is displacement, then your problem is over. Right? This is the way to calculate distance and displacements here. Right? Now let us see some more examples. Some more higher level examples. A man moves 4 meters east and 6 meters north and 10 meters west and 5 meters south, and then 4 meters vertically up. Then calculate distance and displacement. Right? So calculating distance is easy, because all you add 4 plus 6 plus 10 plus 5 plus 4. How much is this? 29 meters is the distance. But calculating displacement is difficult in this process. Okay, so let us see what is the difficult process first. 4 meters east, he is starting from here. 4 meters east is this only, this side, right? 4 meters. Next 6 meters north. North means just you draw first diagram directions. East, west, up is north and down is south. So from here north means up. Okay, up how much? 6 meters. Next from this point west, this side, how much? 10 meters. Means we should draw more than this. This is 4 meter, then 10 meter is this. Now here, from here 5 meters south. From here 5 meters south means up to this. We should not exceed this one, as this is 6, this is 5 meter. Let us take. Next, then from here 4 meter vertically up. I cannot draw on the paper vertically up, because vertically up means this is. Okay, he is climbing a electric pole or tree or something vertically up, right? I am drawing that as this direction. How to calculate displacement in this case? Right, Nana? So this is the displacement. Initial point, final point. How to calculate this? For this we use a vector concept. See how the problem will be easy when you use vectors. If you did not see the vector videos, then you go first and see the vector videos and come here. Right? Now see how I am writing. 4 meters east. In the direction of east, what is the unit vector we have taken? I cap. Right, Nana? X axis, Y axis, Z axis. Similarly, in the west, minus I. North, J cap. South, minus J cap. Vertically up, plus K cap. Okay, na? Vertically up, plus K cap. Vertically down, minus K cap. Remember that. Now tell me, 4 meters east means 4I. 6 meters north plus 6J. North means J only, na? Right. 10 meters west. West is minus I. So minus 10I. Right. Next, south. 5 meters south. South is minus J. So minus 5J. 4 meters vertically up. Vertically up is taken as plus K. So 4K. This is the displacement vector. Now see that 4I minus 10I minus 6I. Okay. 6J minus 5J, that is plus J, plus 4K. This is the displacement vector. Then what is the magnitude of displacement? Root over 6 square plus 1 square plus 4 square is 16. That is root over 36 plus 137 plus 16. Root 53 meters is the displacement. Got it? Very easy when you use vectors concept. We have taken the unit vectors east as I, west as minus I, okay, north as plus J, and south as minus J. Vertically up is plus K, vertically down is minus K. Use this and you can solve very easily. Now let us see for your practice one example, one more example. A man moves 10 meters north, okay, then 5 meters south, then 6 meters east, and then 8 meters west, then 2 meters vertically down. Okay, then what is the displacement vector? See that 10 meters north. North is taken plus J cap. So 10J. South is minus. So minus 5J. 6 meters east is plus. So plus 6I minus 8I minus 2K. Vertically down is K. Completed or not? Yeah, very easily. That is, first let us see I and I minus 2I, JJ plus 5J, because 10J minus 5J, minus 2K is our displacement vector. So magnitude of displacement vector is root over 4 plus 25 plus 4, that is equal to root 29 plus 3, 33 meters is the displacement. What is the distance in this case? Simply add 10 plus 5, 15, 15 plus 6, 21, 21 plus 8, 29 plus 2, 31 meters. So this is the distance and this is displacement. One can use vector so that your problem will be simplified. Clear, Nana? So in this way you can solve any kind of problems in distance and displacement. So these are the major things you need to remember. By using what we have discussed today, by using that, any problem in distance and displacement now you can solve. Okay, once again you see the video from the first if you are not understood any concept. Clear? So this is today's topic. So if you like the video, just press the like button so that it gives boost to me, and subscribe my channel and share it to your friends. Thank you.